All right. So today we'll be talking about a couple of different things. The first thing we'll cover is array lists, which we've done before. We did it in programming one. So for those of you, I think all of you have taken programming one with me, or you were in programming two last semester. I covered the same topics. We discussed very briefly array lists and what the main difference and benefits of an array list are. So array list is very similar to an array, okay? The main difference is with an array list, it can grow and shrink depending on your requirements. So you can add more objects to it, or you can remove objects from it, right? You can search it, you can sort it just like an array. It just takes a little bit different code to do so. But for this class, the main difference is now we're doing array lists, arrays, objects of our own unique classes. So for example, we have an automobile class. We can have an array list that stores automobile objects. We have an athlete class. We can have an array list that stores athlete objects, right? And again, it grows and it shrinks depending on what you need to do. I personally like array lists because of that factor, right? I can add to it, I can subtract from it. However, if we think efficiently, array lists are less efficient than a standard array. The reason being is a standard array, it allocates sequential memory, right? So each index inside an array is right next to its predecessor in memory. Whereas with an array list, it's less defined. It can be, anywhere in memory. It's just pointers to those different objects. So array lists are a little bit more efficient. However, they do take up a significant block of memory, right? So it's just based on your requirements, which one you can use. In today's programming, memory is less of a consideration because it's cheap and it's so abundant, in regards to what it used to be anyway. So using an array list versus an array, that consideration is less so dependent on your physical hardware requirements, but it may come into a play depending on your programs. So for example, in my research, it's all about efficiency. So I chose to use arrays over array lists, right? Because I needed to be fast, almost instantaneous, and arrays are faster than array lists. So again, if we look back at our array, once you initialize an array, you cannot change the length, right? It's going to be, if you make an array of 10, it's going to be 10 for the entire lifespan of that array. Also, there is no built-in method to clear the contents of an array. There is no built-in method. You'd have to go through each individual index, set it equal to null if it's an object array, set it equal to 0 if it's an integer array, or an empty string if it's a string array. Also, there is no built-in search method within an array. Array list, you can search for something. An array, you cannot. Later on, as you get better at programming, there's also something called a dictionary, which you would have a key and a value pair inside of your dictionary. Now, this is a tangent. This is not related to array lists. But dictionaries are really good if you have, say, for example, a unique key. You want to store it in as that key, and based on that key, you have other values. So, for example, let's say we have a whole bunch of athletes. I want to store all these athletes by first name. So I would have a key, Candace Parker, LeBron James, Serena Williams, Roger Federer, so on and so forth. That would be their key, and I can search for them by name. Once I search for them, I would get an object. But that's a dictionary. We won't cover dictionaries in this class, but there are certain use cases where you could use a dictionary. Anyway, back to an array list. They're very similar to arrays. The difference is items can be added, removed, and modified. Arrays, you can modify things, but you can't add and remove objects. There is a built-in clear method, and there's a built-in search method. So there's a lot of benefits from using an array over an array list. I'm sorry, using an array list over an array. So how do we declare array list? So what we do is we first say array list, Then we have our two little, oh, they're not called carets. They're less than and greater than symbols. I'm just going to call it that for right now. And then we put in the type that this array list will hold. So for example, I want to create an athlete array list. I put an athlete, be mindful of the capital A. That signifies that I'm talking about the athlete class. And then whatever I want to name it, so athletes. Same thing with automobiles. So this actually should say automobile, no S. So array list automobile cars. All right, I'm creating an array list of automobiles. So now I can add automobile objects to this array list. How do we instantiate it? So you say whatever your name is equals new array list, less than, greater than, and then your parentheses. You can omit the less than and greater than here. You don't really need this here. You can just do the open and close parentheses. Same thing goes for our automobile array list. You can omit this less than and greater than symbols and just have the parentheses. How do we do that all in one line? So just like an array, we say array list, the type, the name equals new array list. Automobile array list, the type is automobile, cars equals new array list. Same thing. Again, this is just another data structure that you can use in programming, depending on your use cases, right? If you need something that can grow and shrink over time as you add new objects, subtract, array list is really good for that. So how do we add? It's basically whatever the name of your array list is, dot add. Let's go to some code. So if we look back at assignment 7, I'm just going to go off of assignment 7. I did modify this a little bit, if you remember. I just made it to where it's one thing at a time, and I did the instance of all that stuff. But let's say we want to read in different athletes again. So let's say system.out.println, please enter the number. Actually, I don't need them to say that actually, because an array list can grow and shrink. I don't need to know how many they want to enter in. I just need to have them an option. So system.out.println, system.out.println 2, I'm going to say 2 is to end the program. All right, so if I read in at 2, the program ends. And then I'll just do a while loop up here. So while option, actually I'm just going to do while true. While true. That way it'll just keep looping, and I'll just put a break statement inside my while loop. So I'll say if option equals 2, I want to break the while loop. All right. So what I'm doing is I create a while loop that loops through indefinitely. Right. I give the user the option. Do you want to create a tennis player or a basketball player? Or do you want to end the program? Right. I read in that option. If that option equals a 2, that means they want to end. I want to break the while loop. The program ends. Right. So let's create an array list to add athletes to. Array list, athlete, players equals new array list. So I just instantiate an array list. And typically, if I didn't already have this, it's going to want you to import your array list here. So, you know, NetBeans has a shortcut, or you can click over here, add import. All right. Then all I have to do is now to add the new player, right? I'm going to say athlete equals create athlete, calls our method to create the athlete object. Then I'm just going to add that athlete to my players array list. Players dot add athlete. And there we go. I add that athlete to my array list. All right. And then I'm going to modify my display details method down here to take an array list of athletes. And then I'm going to loop through this array list. The method for an array list is not length, is dot size. Dot size tells you how many there are in there. And then you don't access an index and array list like this. You do athletes dot get I. And so I just modified the display details method to work with an array list. Right? Athletes dot size gets me the total length of my array list. If I want to get an individual athlete or get an index, I use the get method. All right, and now you see this is less stringent than using an array. With an array, we had to ask how many athletes do you want to add, and then we had to create an array of that size, and we have to make sure that we don't go beyond that size. With an array list, it can grow, I don't know about indefinitely, I don't know what the max size of an array list is. I imagine it's the max size of the allocated memory for your program, which is decided by the operating system. But you can keep adding athletes after athletes after athletes, depending on what you want to do. So if I run this, where is my console? And my console disappeared. There we go. You see it goes into my while loop right here. What type of athlete is player? It just says player. What type of athlete is player? If I enter a 2, my program should break, and then it stops. If I run this again, I enter in a 0, tennis player, Serena. Wins, I'm gonna say 50, losses 30, which is not true. And then I can end it. Boom, I end it. And when I end it, I do want to print out the details of my array list. So if players, which is my array list, what's the condition that I wanted to print? If I've actually added some players to it, right? If I didn't add any players to it, I don't want to print. So I'll just check if players dot size is greater than 0. That would mean there's at least one player or at least one athlete in my players array list. I would call display details players. And then I call the display details for my players array list. That way, if I run this again, it'll print out all the details. So let's do a tennis player again. Serena, 59, 250. I'm gonna say she has 10 losses. The organizations. And then I'm going to end it. So I'm going to enter a 2 down here. And it should print out my athletes. Yep, 4'11", that's not right, but it should be 69 inches. Does that make sense? Using an array list here and how I modified everything?
Yes, sir.
Anybody have any questions? No questions? All right. So let's keep going. So that's how you add. You remove items by just saying whatever your array list name is, dot remove, and then the index of your athlete. So that implies you have to know the index of the athlete you're trying to remove. If you just remove index 2, you won't know which one you're removing. Right? So you must know the index before you remove it. When you do remove something, all of the items that came afterwards are pushed forward. So for example, if you remove index 0, all of the ones from index 1 on, they get pushed up. So index 1 becomes index 0, so on and so forth. And that happens for whichever index you are removing. So setting the value, if you already have something in your array and you know the index, and say, for example, I want to update one of my athletes, I would say list.set, the index of that athlete, and then whatever I want to set it equal to. But it must be a new athlete object, or it could be the same object, it doesn't matter. But that value right here must be the type of whatever your array list is. So if I have this, create athlete, players I'd add, then I say players dot set index 0. I could do new athlete. That basically just creates a new athlete object. And it sets index 0 to a new object. Right? But when I set it, again, it must be whatever type my array list is. So if I have an array list of integers, that must be an integer. If I have an array list of strings, that must be a string. In this class, we're working with objects more than anything, so that must be an object. Getting, you saw me get that athlete based on its index when I was printing. So down here, athletes.getI, I'm printing. I'm getting the index at, I'm getting the object at index I. Searching. So you can search. Now this is tricky for objects, right? Because when you search, you're searching for that value. So if you're searching for an athlete, you have to pass in the entire object, right? And it searches for objects. I don't know exactly the search criteria that's used built in, but I would just say kind of avoid that for now, unless you want to look deeper into it and try to see what that search is using. I believe it's using a compare to. So if that's the case, you have to implement compare to. And that's what I'm going to get to here. So when you have objects and you want to sort something, the default sorting algorithm will sort based on comparing the object to the other. So for example, if I have an array list of strings, and I'm just an array list of all the alphabets, A through Z, it's going to compare A to B, B to C, C to D. And based on however they fall, it's going to sort my array list. With objects, however, it's going to compare them to the strings, right? I mean, to the pointers, right? And if those pointers don't compare, it's going to, I don't know exactly what it's going to do, right? It's not going to do what you think it should do. It's not going to sort it in ascending order. So as the programmer, we can override and implement our own comparing method, right, for our objects. So for example, let's say when I sort my array list, I want to sort it based on the name of my athletes, all right? So if I want to do that, I do need that actually, equals. So if I want to sort them based on the name, that means I have to implement my own sorting logic, all right? I have to implement the logic that's going to be used by whatever sorting algorithm. And that logic is the compare to method. And one thing we need to do, and we'll discuss even further when we talk about abstraction, whatever the object we want to be sorted, it must implements comparable. That makes it so that this object can be compared to another one. One athlete can be compared to another one. And you see how I have an error right here, right? Athlete is not abstract and it does not override the abstract method compared to. So we must override that method. I'm going to click here, implement all abstract methods. And now we have this compare to method, right? This is where we would put our sorting algorithm, okay? So what we want to do, again, we want to sort them based on their names, right? And we kind of did something similar before with our equals to method or our equals method. We did it based on name. So let's do the same thing with compare to. And if you look up here, we're comparing this object. So if we say we have athlete 1, athlete 2, LeBron James and Serena Williams, we want to compare LeBron James to Serena Williams. All right. So object O will be that other object we're comparing. So Serena Williams. If that's the case, we do need to do an explicit cast, athlete other equals athlete O. That says we want to convert O into an athlete object, okay? But that implies that we know we're only comparing to athlete. If I try and pass an automobile in right here, this line will result in an error, right? We will get an error because it's trying to cast it to an athlete. If that object is not an athlete, it will get an error. And again, that goes back to polymorphism, right? We can pass in a superclass, which is object, and convert it to a subclass, which is athlete. For this comparative method, again, we want to compare it based on the name. And the beauty about strings is strings have built-in methods. So we can just do return this dot get name dot compare to other dot get name. And it'll return whatever that comparative method results in. Okay. So it does it alphabetically, right? A to Z. So if this name goes before this name, it's going to return a negative number. If they are equal, it's going to return a 0. If this dot get name goes after the other dot get name, it's going to return a positive number. And that's how it does its sorting, right? Based on those values. So now that I've done this, I can sort my array list, right? So what I'm going to do is up here, I'm going to display the details. Then to sort, we need to say collections dot sort players. And then I'm going to call my display details again. So hopefully it'll sort our players array list. I'm going to print it, sort it, then print it again. All right, so you can see it's comparing based on the name. So if I run this, tennis player, let's do Serena again. I'm going to do Candace Parker. Let's just do one name because it's going to give me an error if I do more than that. Let's see. Let's do one more for just to add more objects to an array list. Height. All right, and then I'm going to end it. And so when I end it, it should print Serena, Candace, and then LeBron. It's going to sort it based on their names. So then it should print Candace, LeBron, Serena. So you see the first time we print it, it says Serena, Candace, LeBron. And then we print it again after we've sorted it, Candace, LeBron, Serena. So our sorting logic is working correctly. It's sorting it based on name. And we can do whatever we want. We can sort it based on height. We can sort it based on, if we're just talking about basketball players, we can sort it based on the points scored or rebounds. And if you think about it, this is the same logic that's used on a lot of the websites and apps that you all use every day. They sort it based on whatever your criteria is. If we're talking about an inventory system, we would sort our objects, our items, based on price. We can sort it high to low or low to high, whatever it may be. Right? If we're talking about a vehicle inventory system, we can sort it based on trunk space or price high to low, low to high, whatever it may be. So if I do want to reverse the sorting, I believe we just do collections. So if I want to sort it from, you know, the inverse way, so where Serena would go first, then LeBron, then Candace, I think it's collections dot reverse order. Yeah, collections dot reverse order. So I say collections dot sort, whatever my array list is, then the argument collections dot reverse order. And that'll tell it to reverse the order. Any questions? I believe that's it. And then we talked about the size, which gets you the length. Oh, the last thing is you can clear an array, basically clear all the contents, and the size would go back down to 0. If you just do athletes or whatever, players dot clear. All right. If you want to reset your list back to 0. And that's it for array lists.